Hello and welcome back. This is Computer Science and Engineering 120, Learning to Code. This is Module 9, Organizing Code, Part 1, Using Functions. In this part, we'll give an introduction to functions, including why we use functions, the advantages that they offer, as well as how to define functions in JavaScript and how to ultimately use them and the best practices for using them. Functions are units of code that you can provide inputs to and which produce an output. Using functions provides a way to organize code. By placing snippets of code inside of functions, it provides a way to organize them into one logical unit that can then be reused elsewhere in your code base. Using functions makes code easier to test and maintain because it isolates particular functionality into one unit. Functions also provide a way to achieve procedural abstraction. The logic, operations, and processes used to compute a result are encapsulated inside of a function. We don't really need to worry about the details of how the computation is actually executed. Instead, we just use it. We become consumers of code instead. A prime example of this is the math library's square root function. We don't know how it works, and we really don't care. It just provides us a result. If we were to actually implement this function, we would need to worry about the details, but just using it, we don't have to. In JavaScript, you can define a function using the function keyword. In general, a function needs a name, which also called an identifier, a list of parameters, that is input to the function, and a body containing the code to actually be executed anytime the function is invoked. In particular, we use the function keyword, followed by the identifier, in this case miles2km, followed by parentheses inside which any parameters are placed. The function body is defined by opening and closing curly brackets. We also have a return value inside the function. Function parameters are essentially variables available to the function. You can, but it's not a good idea to redefine them. They can be used in any expression. They have to follow the same identifier rules as any other variables, as do function names. Multiple parameters can be provided, separating them with a comma. Recall that functions compute some result and need to communicate it back to the code that called that function. To do this, we use the keyword return. A function can return any type, a number, a string, etc. A function that doesn't return anything is often called a void function. Forgetting or intentionally omitting a return value will end up returning an undefined value. You call a function just as we've been doing with the standard library functions, by providing values or variables as arguments to the function. Moreover, if the function returns a value that we need to capture, we store that into a variable. For example, we can create a variable x, set it equal to the value 2, and then capture the value computed by the math square root function. Once we've created our own functions, we can use them similarly. Miles to kilometers can either be passed a variable containing a value or a value directly. Let's understand how this works a little bit deeper. When you call a function passing it variables, the values stored in those variables are actually copied, and those copies are passed to the function. This is known as passing by value. The function knows nothing about the original variable. Thus, changing the values of the function parameters have no effect on the original variable. Let's take a look at an example to understand this a little bit better. Here I've created a function called test that takes two parameters, a and b. What it first does is it ignores the value passed to it in a and immediately resets the value of a to 10. To prove that it works, we print it out to the console. Then it computes a plus b, but because a has been changed to the value 10, regardless of what's passed into this function, this value will compute 10 plus b and return that value. Let's go ahead and give it a try. I've created a variable x and set it equal to 5. Y and set it equal to 15. When I pass those variables to the function test, those values are copied and provided to test, meaning that the change to a has no effect to the variable x. We then capture the variable, which in this case should be 10 plus 15, 25, and print out all three of these values. To show that x is unchanged, it should print out 5 here. Similarly, it should print out 15 because y is unchanged, and it should print out the result 25. And it does. Inside the function, it prints 10 because the variable a, the local variable a, has had its value changed to 10. When calling a function, passing arguments is actually optional. This can lead to some confusing behavior if we're not careful. If an argument is not passed to a function, the parameter's value becomes undefined, and using undefined in any expression will lead to undefined or unpredictable behavior. Let's take a look at an example. Here I've created another function called min that takes two parameters a and b and returns the minimum value. If a is less than b, it returns a, otherwise it returns b. I've created two variables, x and y, and set them equal to 10 and 20 respectively. I can call min on x and y, which returns the value 10 as expected. However, when I only pass one argument x here, b will be undefined in this function. Comparing a value 10 to undefined will lead to undefined behavior. Consequently, it'll return undefined. Omitting both values means that we're comparing undefined to undefined, which again will return undefined. This can actually be seen as a feature. We can define functions with optional parameters to either provide a sensible default for the value, or we can change the behavior or meaning of a function based on the number of parameters that the user passes. We've already seen this, for example, in the jQuery library. The CSS function, you can pass it one parameter or two parameters. One parameter changes the behavior of the function to get the value, and passing two parameters changes the behavior of the function to actually set the parameter. This is achieved by checking a parameter, whether or not the parameter was passed, by making a comparison to the keyword undefined. Doing this makes a function more versatile in that it can have multiple behaviors depending on the number and type of values that are passed into the function. Declaring a function makes it globally scoped, which means that any piece of code in your application can actually see it and use it. This has the potential to what is usually referred to as polluting the namespace. For example, suppose that two libraries, say jQuery and Bootstrap, both defined a function called showPopup. They would be in conflict. You can't have two definitions of the same function. The solution is to organize functions into objects as members. We've seen this before with the standard math library. Rather than a globally scoped square root function, the square root function is placed inside of an object called math. That way we can organize multiple functions into one logical unit and avoid conflicts. We can do this with our own code using the following syntax. We can create a variable, an object, called myFunctions. Then we can use the syntax of an object. Here we provide the function name followed by a colon and the function keyword. This is slightly different syntax than if we were declaring this to be a global function. Multiple functions can be delimited using a comma. Once we've done this, similar to math.squareroot, we can now use myfunctions.min or myfunctions.miles to kilometers to access and invoke our functions.